Okay, so today I wanted to go over specialized versus generalized transduction with you guys. So this is a mechanism of horizontal gene transfer where instead of a bacteriophage actually successfully causing infection, it ends up inadvertently carrying bacterial DNA from cell to cell. All right, so the first one is generalized transduction. In generalized transduction, this can be done by either virulent phages, such as our favorite virulent phage T4, or it can be done by temperate phages that are in the lytic life cycle. So in this scenario, what would happen is our host cell would be attacked by T4, and the first step after attachment is that the T4 genome gets injected into the host cell. So here's our T4 genome. The next step is that the host cell genome gets destroyed and broken up into tiny pieces. The cell basically turns into a phage-making factory, and so what you end up with is lots of T4 genomes interspersed with pieces of the host cell genome which was destroyed. But it can be any piece of the host cell genome. So normally what would happen is as you get new virions forming, the virions would pick up a T4 genome, they would cause lysis of the host cell, and they would go on and successfully infect other bacterial cells. But sometimes what happens accidentally is that instead of picking up the T4 genome, a piece of the host cell genome gets picked up. Phage heads can only hold a particular amount of DNA, and so if a piece of the host cell genome gets picked up, there's no room for the T4 genome to fit in there now. So this is a defective phage, also known as a transducing particle. This particular phage will still lyse the host cell, and it can go on and attach to other bacterial cells, but it won't successfully cause an infection. Instead, what it will do is it will inject the piece of the host cell genome into the new cell. And again, it could be any piece of the host cell genome that's picked up with generalized transduction. Now with specialized transduction, this is only going to be done with our temperate phages after they have been in the lysogenic life cycle. So remember, the lysogenic life cycle is where the phage genome has actually been successfully incorporated into the host cell genome. Different temperate phages get integrated at different locations. Our favorite temperate phage, lambda phage, always gets incorporated in between the host galactose and biotin operons. And remember, when it's incorporated, it's referred to as a prophage. Now, once certain signals are received, particularly signals that cause damage to the host cell DNA, the phage undergoes what's called induction, which is where it will switch from the lysogenic to the lytic life cycle. And what happens in this case is that our prophage gets cut out. We end up getting replication of lots of our phage genomes, and then we make new virions that are packaged with the proper phage genome. But sometimes, and this is what actually leads to specialized transduction, instead of correctly cutting out our phage genome, things get shifted a little bit, and there's a mistake in how the prophage is excised. When that happens, what you end up with in your new virions is a portion of the phage genome with a portion of the bacterial genome. And so again, this is a transducing particle because a portion of the phage genome has been left behind. This is no longer a fully functional phage. It can go on and attach to other bacterial cells, but instead of successfully causing infection, it will end up injecting a portion of, in this case, the biotin operon. Now again, for specialized transduction, it's only certain locations of the genome that can be transferred. It's only the locations around where the prophage actually incorporated. Because the reason that you're gonna have bacterial DNA in the phage is because of that improper excision.